What's up, guys? We are going to continue here with chapter 8. We're looking at section 2 where we're talking about reflections and reflections in symmetry. So here what you're going to be learning today is to graph reflections in the coordinate plane and to identify lines of symmetry. So let's go ahead and jump in here. Here's some vocab. You want to pause and make sure you copy all this down. A reflection is a transformation that flips a figure over a line. This line is the line of reflection. Like translations, reflections change the position of a figure but not its size or shape. It's just moving it in the plane. All right, sometimes you hear this called a flip. All right, so a reflection is a flip. In the diagram, C and C prime are the same distance from the y-axis, which is the line of symmetry, or the line of reflection. The segment connecting C and C prime is perpendicular to the line of reflection. This is an important concept that we'll probably investigate a little bit later. But for now, I just want you to know, if this is my line of reflection and I connect the image and what's called a pre-image, if I connect the image and the pre-image, then that creates a perpendicular line. In other words, that's a right angle. Let's keep going. I think sometimes you guys just need something motivational to help you keep moving. So I found this really solid quote by somebody that we all love that I think will just really get you pumped and ready to go. So one of the more intelligent quotes I've seen in a long time. So here it is. Yeah, Chewbacca really said that. And I don't know about you, but that's one of the things that helps me just get through the day. Thinking about that day in and day out. All right, so graphing reflections of a point. It says graph the point A, 3, 2, then graph its image after it is reflected over the x-axis. Name the coordinate of A prime. So I'm going to go ahead and change here to a better color. All right, so first thing is to graph point A, which is 3, 2. And then it says reflect it over the x-axis. Well, here's the x-axis. So if I'm reflecting this, I need a line that's going to go perpendicular to this. That's the same distance away. So in other words, I go 2 to get to my line of reflection. So that means I come down here 2 more. And that's A prime. And then it says name the coordinates of A prime. Well, A prime is going to be, let's see, that's 1, 2, 3. And then down 2. So there's my coordinates of A prime. All I did was just change that y value. So here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so this is what I got. Here's the original point D, and then when translated or reflected over the y-axis, it's coming this way, and there's my new point. There's my ordered pair. So let's keep moving along here. All right, graphing reflections of a shape. It says graph triangle BCD and its image after it is reflected over the line through 1, 3, and 1, 0. All right, so here is my line that I'm reflecting over. And remember, every single point on here is going to go to this line of reflection, and it's going to be perpendicular. So I need a line that's going here. And it takes 2 units to get to that, so that means that my next point is going to be here. Let me label this triangle so that we know, so we have some things. So I have B, C, D. All right, so here's C, which means this is now C prime. This one is a 1, 2, 3, 4, 5 there. So for my B prime, I need to go 1, 2, 3, 4, 5. Right here is going to be B prime. And then to create D prime, it's 1, 2, 3. So to go this way, 1, 2, 3 again. And that gives me D prime. Last thing I need to do is to connect my points. All right, so there is my new triangle. It tells me to name the coordinates of the vertices. So B prime, let's see, is 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4. And C prime is 1, 2, 3. And then 1, 2, 3, 4, 5. And then D prime is 1, 2, 3, 4. And then 1. All right, so there are my ordered pairs. That's what you do to answer this one. Here is one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here is what I got. Check your answers against this. There's all my ordered pairs. Big thing here is going to be making sure that you write these out exactly correctly and that you do your drawing correctly. Let's keep going. Reflection symmetry. You'll want to pause and copy this down. It says, if a figure can be reflected over a line so that the reflected image matches the original figure, then the figure has reflectional symmetry. The line that divides the figure into mirror images is called a line of symmetry. So again, make sure you have this copied, and let's see how this plays out. It says, draw the lines of symmetry of the snowflake. Let's switch colors here to something that's going to be a little easier to see on that blue. I'm going to go with good old-fashioned red here. All right, so draw the line of symmetries. A line of symmetry is going to be where if I were to fold this figure in half, it lines up perfectly with itself. So I see one right here, so bear with me as I try to draw that. So there's one line right there because I could fold this and it would match over. In fact, in between all these little spokes are going to be more lines. So here is another one. And there's that one. Now, that's not all of them. What if I fold right along the spoke itself? Well, then this and this would line up, and this would match up. So that right there is also going to be a line of symmetry all through all of these different spokes. Now, that's it. There's nowhere else I could fold this thing that's going to fold that. So how many lines did I draw? Well, I have 1, 2, 3, 4, 5, 6, because if I count this one, I already counted it down here. So we would say that there are 6 lines of symmetry. And then there are the 6 lines right there. All right, so that is it for this one. Here's one for you to try. You're going to want to copy this flag down as best you can. I'm not asking for great art, but copy the flag down and then draw all the lines of symmetry for this one. All right, so the answer will be up in 3, 2, 1. All right, so that's what I got. There's only one line of symmetry, and that's because this figure and the colors are a little bit different on that. So the shape, if I'm just looking at a rectangle, would have 2 lines of symmetry, but because there's images on here, it means that there's only one. So if I fold it in half right along that line, it'd match up. That is the only way that happens. So let's keep going. I believe that's it for today. Yes, it is. So hopefully you took notes. I will see you all in class.